Okay, good afternoon everyone. Today, ang pag-aaralan natin ay motion. Yun yung isa sa mga unang pinag-aaralan pagdating sa physics. Of course, ay dapat matutunan natin yung kung paano mag-describe ang motion ng isang object. The simplest type of motion, of course, is a straight line motion or in mathematics, or pag nag-include tayo ng mathematics, we call it a one-dimensional motion or motion along a straight line. So, sa araw na ito, pag-aaralan natin yung mga physical quantities na nagde-describe ng motion. Okay, tulad ng displacement, time, average velocity, velocity, average acceleration, at saka acceleration. At titingnan natin kung paano sila related sa isa't isa. Habang din-discuss natin yung concepts, magdi-discuss din tayo ng mga exercises kung paano gamitin yung mga equations of motion na ito or yung tinatawag na kinematic equations. Okay. So, we can begin to describe motion with the help of this figure. So, sa figure na ito, ay merong dragster, okay, or race car driver na nagmo-move from a position P1 to a position P2. Okay, and yung difference between P2 and P1, okay, along with yung direction ng kanyang motion ay tinatawag natin na displacement. So yung displacement is yung distance na tinravel ng dragster na ito from an initial position to from an initial position to a final position. So, yung P1 na yan ay tinatawag natin na initial position, and yung P2 ay tinatawag natin na final position. Okay. So, to describe position, kailangan natin i-refer yung movement na yan with respect to a coordinate system. So, typically, ang ginagamit natin yung Cartesian coordinate system. And since this is one-dimensional motion, okay, motion along the x-axis lang i-consider natin. Okay? Kasi typically yung motion naman is horizontal. So, ibig sabihin motion along the x-axis. So, we're going to use a one-dimensional Cartesian coordinate system. Okay? So, makikita nyo rito na ito yung origin dito sa point na ito. At ito yung x-axis. Okay? Yung positive x-axis points towards the right. Okay? And yung position P1, yung initial position ay inassign at this point. Okay? Not necessarily dun sa origin. Okay, yung point na yan ay may position na x1, yan yung variable na assigned sa position na yan at equal sa 19 meters. Ang ibig sabihin nito is this distance is 19 meters from the origin. Kasi ang origin is 0, 0. Right? Okay. Itong pangalawang position na P2, okay, ay nasa position na 277 meters from the origin. Yung displacement ngayon is from position P1 at x1 equals 19 meters to position P2 at x2 equals 277 meters. So ito yung ating displacement. Okay, from P1 to P2. So yung displacement ngayon is described by delta x. Ang delta x is yung location nung P2, which is at x2, minus yung location ng P1, which is at x1. In general, pwede natin itong isulat as the final position minus the initial position. Okay, so yung displacement ay yung difference between the final and initial position. Note that this is a vector quantity kasi dinidescribe niya yung direction ng motion, okay, from P1 to P2. In this case, yung displacement ay positive kasi lumalaki yung displacement from 19 meters to 277 meters. Note na ang displacement is positive only because we chose to have the tawag dito, the origin at this point. Okay, nilagay kasi natin yung origin dito and then ito yung dinrawing natin na x-axis. Yan yung coordinate system na ni-refer natin dun sa kanyang motion. Okay? Okay, so yan yung definition ng displacement. Ngayon, yung there's also an associated time at which yung dragster is located at a particular position. Ibig sabihin, dito, inassign natin na at x1 equals 19 meters, yung time nung dragster is 1 second. So 1 second from the starting position, nandoon na yung dragster sa position na 19 meters. And then 4 seconds after the start, okay, yung dragster ay nasa position na 277 meters. So there's also a time, okay, which we define as the final time minus the initial time. Okay. Now, we also define what's called an average velocity. Okay. Basically, an average velocity ay symbolized by V and then average. And then sometimes naglalagay ng subscript or in this example, kung titignan niyo, subscript na average dash x, okay, to signify na it's the average velocity along the x-axis. Okay. Ang definition ng average velocity is precisely yung nakasulat dito. So, delta x over delta t. So basically, ang average velocity is the displacement over time. Okay, and since displacement is a vector quantity, yung average velocity is also a vector quantity. So in this particular figure, yung displacement is 277 meters minus 19 meters. Okay. And 277 minus 19 is 258 meters. Tapos yung change in time over that distance is 4 seconds minus 1 second, which is 3 seconds. So ang average velocity niya is 86 meters per second. Okay. So, mapapansin nyo na ang displacement at ang average velocity ay hindi nagde-depend sa kung paano nagmo-move yung dragster. Ibig sabihin, whether the dragster or the race car driver turns left or right or tawag dito, has a motion na pa-curve, di ba? Hindi nagmamatter yon. Ang nagmamatter lang ay yung initial position at yung final position. Anything else that happens in between, okay, ay walang tawag dito, walang ay hindi significant sa definition ng displacement at saka ng average velocity. Okay. So, now it's also important to note na yung displacement at saka average velocities ay sobrang dependent sa pinili nyong coordinate system. Okay, so if you choose, for example, a coordinate system na nandito, okay, na ganito, for example, yan yung coordinate system. Okay, so dito ko nilagay yung origin at x1. So, ibig sabihin, yung x1 ngayon, i-define ko as 0 meters. Okay, kasi, yan yung yan yung pinili ko. Okay. Then, ibig sabihin, itong position na ito is x2, which will be equal to 258 meters. Since pinili ko na ito yung starting, yung nilagay yung origin dito, yan din yung aking t1, which is 0 seconds. And ibig sabihin, itong x2 dito, yan yung aking t equals 3 seconds. So, in the chosen, in this green coordinate system na pinili ko, okay, the average velocity will be 258 meters divided by 3 seconds is equal to 86 meters per second, which is the same as dun sa coordinate system na kulay blue na dinefine ng book. So, anong point dito? Ang point dito is you can choose. You're free to choose the coordinate system that you want. Pero once you choose that coordinate system, you define all these variables in terms of that coordinate system. Okay? If we look at this figure, dito naman sa figure na ito, makikita ninyo na paatras naman yung, hindi paatras, ang motion ng vehicle dito is towards the left. Okay? Ang pinili na coordinate system dito, okay, ay ito yung origin at yung x-axis, positive x-axis ay pointing towards the right. Now, yung truck started at position P1, which is located at x1 equals 277 meters. And at position P2, yung truck ay nasa x2 equals 19 meters na. So, in this case, okay, so at yung truck at located at P1 ay nakita at t equals 16 seconds. And after some time, nasa P2 na siya, yung time na yun is 25 seconds. So yung displacement in this case, okay, yung displacement delta x is, remember, it's x final, the final position minus the initial position. Ito yung kanyang final position. So 19 meters minus yung initial position niya na 277 meters. So in this case, this is negative 258 meters. Yung time, of course, is the final time, which is 25 seconds minus 16 seconds or 9 seconds, yung time difference. So yung average velocity ngayon, which is defined as delta x over delta t, is equal to negative 258 meters divided by 9 seconds or negative 29 meters per second. So, makikita nyo dito makikita nyo dito na vector quantity ang average velocity, particularly because of particularly from the negative sign. The negative sign indicates na yung motion ay towards decreasing values of x from 277 meters to 19 meters. Okay? Yan ay relative din sa piniling, anong tawag dito? Piniling coordinate system. So negative 29 meters per second relative to this coordinate system. Okay, a coordinate system that's going to the right, yung positive x-axis. Again, i-demonstrate ko lang na you are free to choose yung coordinate system. Okay, you can choose a coordinate system that looks like this. Dito ko ilalagay yung origin at pipiliin ko na yung positive x-axis ay towards the left. Okay. Ano magiging implication niya sa displacement? So, ang displacement ngayon will be ang final position. Okay, so kung ito yung origin, hindi magandang piliin niya na coordinate system kasi hindi tayo sure sa location ng origin relative dun sa mga positions na given. Ito yung pipiliin kong origin instead. Okay. So kung yan ang pinili kong origin, that means yan yung x equals xi equals 0, initial position equals 0, or x1 equals 0. Okay, which means na itong point na to will be x2 equals negative 258 meters. 258 meters. Okay. So positive 258 meters. Okay, bakit naging positive? So, klaruhin lang natin. Ang final position kasi is 258 meters relative dito sa origin. Okay, remember this is the positive x-axis. And then yung origin is at 0 meters. Okay? So, ito yung pinili kong coordinate system. Pinili ko na towards the left ang positive x-axis. Okay? So, kaya dito, relative to the positive x-axis, the vehicle is moving towards increasing values of x. Okay. Yung delta t, of course, is the same. We can choose this to be 0 seconds, and then ibig sabihin ito will be 9 seconds. Okay, so yung average velocity in this case is 258 meters divided by 9 seconds, or positive 29 meters per second. Okay, so again, ang point dito is you're free to choose a coordinate system. Okay? So, anong implication nito ngayon pagdating well, particularly pag nag-check na ng papers. Ang ibig sabihin nito is when you submit your solution, you have to first define a coordinate system. And when I say define, you have to draw the coordinate system dun sa solution mo. It should be included. It's mandatory. Kasi kung walang coordinate system, paano ko alam kung ano yung pinagbabasihan yung mga positions? Okay? Anong pinagbabasihan yung time? At saka anong pinagbabasihan yung physical quantities? Okay? So, this is very important. Kung walang coordinate system, then your solution will not make 100% sense. Okay, and then once you define a coordinate system, okay, then you can define the variables, okay, the physical quantities relative to the coordinate system. Okay. Okay. Now, in some cases, pwedeng i-describe yung motion ng isang particle using or graphically. Okay. In this figure, yan yung basically ginawa. So graphically, ang pinapakita dito is yung position versus time. So this is a displacement. Oops. Displacement versus time graph. Okay, so x versus t graph. Note na pinapakita dito kung ano yung units ng displacement at ng time para klaro dun sa graph. And of course, pinapakita din kung anong klaseng graph to. So this is a position versus time graph. So when you take a look at the graph, ang unang-una yung gagawin is ano yung y-axis at ano yung nasa x-axis. So pag nakita nyo na, yung y-axis is position and the x-axis is time, then you immediately know na itong graph na ito is a position versus time graph. Now, if you see a graph ng displacement versus time, Okay, na ganito yung itsura. Okay, curve or ang description natin dito is parabolic. Okay, mukhang parabola or half a parabola. Okay, then you know, okay, na itong object na ito has acceleration. Okay, kasi nagbabago yung kanyang speed. Okay, it will be clearer to you in a little while. Okay, if we go back dun sa example ng dragster, okay, yung dragster started at 19 meters. So ito yung x1 na 19 meters. And it ended up at P2, which is at x to 277 meters. Okay, so ito yung P1 at saka ito yung P2. Yung position niya at 19 meters started when at 1 second, and position niya at P2 ended at T equals 4 seconds. Okay, so ito yung, ayan, nakalagay 4 seconds and then 1 second. So, yung average velocity ngayon, okay, if we interpret it on this graph, sinabi natin kasi it's just x1 okay, minus x2 minus x1 divided by t2 minus t1. Okay? Now, ano ba yun mathematically? This is the y-axis change, diba? And this is the x-axis change. So it's delta x over delta t. And mathematically, okay, yung delta x over delta t, and yan yung rise over run, that's the slope, okay, of this, supposedly the slope of this curve, okay, defined between these 2 points. Okay, so slope of a line, okay, that connects these 2 points, P1 at saka P2. So ang average velocity ngayon, so the average velocity is the slope of line is the slope of the line in a displacement versus time graph. Slope of the line between any 2 points, okay, in a displacement versus time graph. Okay. Okay. Sinabi natin dito na nag-accelerate yung dragster, no? Pero hindi yun nakikita dun sa average velocity. Okay, bakit? Kasi nga, hindi naman, ang nakikita lang, ang definition ng average velocity is this green line. Okay, and yan, yung green line yung average velocity. And yung blue line ay ang dinidescribe nitong blue line na ito ay yung acceleration. So, makikita nyo na yung blue line is not at all, yung behavior niya described by this blue line is not at all seen dito sa green line na yan. So, pag tinignan mo yung green line, pag green line ang tinignan mo, hindi mo alam kung nag-accelerate siya. Kasi it's not descriptive of yung nangyayari dito sa blue line. Okay? So, in other words, walang pakialam okay, yung average velocity sa nangyayari, sa kung ano man nangyayari between P1 and P2. Okay? Just as we said earlier. Okay? Okay. So, let's consider this example ngayon. Okay. Well, before we consider that example, let's describe one more thing. Okay, so let me just add a new slide here. Okay, and go back to drawing. Okay, so at this point, i-define na natin yung tinatawag na instantaneous velocity. Okay, ang instantaneous velocity is nothing but yung velocity of a particle, okay, at a specific instant of time, okay, along at a specific point, okay, along a given path. Okay, so kung of course, mukhang I mean, nakasakay naman kayo sa kahit anong vehicle, di ba? And then pag tinignan nyo ang odometer ng isang vehicle, di ba, yung odometer na yun, okay, nagbabago at anytime, di ba? So the odometer describes yung speed ng particle, okay, at any point in time. Okay, and if you include yung direction, then that's the velocity. And yung velocity nun at any point in time, that's kung anong nakikita nyo sa odometer is actually yung instantaneous speed. Okay, and if you include yung direction, then that's the instantaneous velocity. Okay, so how do we relate yung instantaneous velocity sa average speed? So we define yung instantaneous velocity, or we use this variable v sub x for the instantaneous velocity, or sometimes we use just simply v. Yung subscript dito just defines kung anong axis directed yung velocity na yun. Okay, and we can relate yung instantaneous velocity to the average velocity, mathematically actually. Okay, when we take the limit, okay, of the average velocity as the change in time approaches 0, or limit of delta x over delta t as delta t approaches 0, or the derivative, okay, of the position of the displacement with respect to time. So this is nothing but yung derivative. Okay, so instantaneous velocity is the change of rate, okay, instantaneous rate of change of the particle's position. In this case, along the x-axis, kasi may subscript na x. Okay, so we can understand this better, this definition better, okay, if we take a look at this example. So this is the example that's in the book. This is example 2.1 sa Young and Friedman. Okay. And sa example 2.1, we have a cheetah which is crouched 20 meters to the east of a vehicle. So yan yung vehicle, and to the east of the vehicle, nandun yung cheetah. Okay. At time t equals 0, the cheetah begins to run due east towards an antelope that is 50 meters to the east of the vehicle. So ito yung cheetah, it starts to run at t equals 0. Nakita niya yung antelope at 50 meters. Okay, from the origin. Okay, kung nasan yung vehicle, kung nasan ka. Okay. Okay, to the east of the vehicle. During the first 2 seconds of the chase, the cheetah's x-coordinate varies with time according to the equation. Okay, x equals 20 meters plus 5.0 meters per second squared, t squared. Okay, for some reason, meron nang nakadiscover no equation na yun Nakaderive ng equation na yun habang tumatakbo yung cheetah. Okay? That happened over a 2-second time interval. So ang tanong ngayon is find the cheetah's displacement between t1 equals 1 second and t2 equals 2 seconds. So from t1 equals 1 second, which is here, and t2 equals 2 seconds, which is here. So ano daw yung kanyang displacement? Find its average velocity during that interval. Okay? And then letter C, find its instantaneous velocity at t1 equals 1 seconds by taking delta t equals 0.1 second, then 0.01 seconds, then 0.001 seconds. Then letter D, derive an expression for the cheetah's instantaneous velocity as a function of time and use it to find Vx, the instantaneous velocity, at t equals 1 second and at t equals 2 seconds. Okay, so we begin with letter A. So pinapahanap sa letter A is cheetah's displacement. And since yung displacement is already described by this expression, okay, all we need to do is to find yung initial position niya or yung position niya at 1 seconds. So 20 meters plus 5.0 meters per second squared plus 1 second squared. So ang kanyang position at 1.0 seconds ay 25 meters. And at 2 seconds, okay, so 20 meters plus 5.0 meters per second squared times 2.0 seconds squared, ang kanyang position is 40 meters. Okay. So yung displacement is defined by delta x. So ang final na position niya is at 2 seconds and ang initial niya is at 1 second. So this is 40 meters minus 25 meters or yung displacement niya is 15 meters. Okay, so letter B, pinapahanap naman yung average velocity. And yung definition natin ng average velocity is delta x over delta t. Ang delta x is, na-solve na natin sa letter A, which is 15 meters. And ang delta t is over 2 seconds minus 1 second. So this is 1 second, so 15 meters per second. Now, sa letter C, okay, kukunin natin ngayon yung instantaneous velocity niya. Okay. Okay. Instantaneous velocity niya, okay, gamit itong equation na ito. Okay. Or more specifically, gamit itong equation ito. Limit as delta t approaches 0, delta x over delta t. So ang gagawin natin is you start with delta t equals 0.1 second. So ang Vx is equal to delta x, which is 15 meters divided by 0.01 seconds. Okay? So ang sagot dito is sorry. Mali. So, ano yung delta t? Ang delta t is the change with respect to t1 equals 1 seconds. Okay, so ibig sabihin ang t2 is 1 second plus 0.1 seconds. So ang x at 1.1 seconds ngayon is obtained from this equation 20 meters plus 5.0 meters per second squared times 1.1 second squared. Okay, ang sagot dyan is 26.05 meters. Okay, so ang velocity ngayon is 26.05 meters minus 25 meters divided by 1.1 seconds minus 1.01 seconds. So this is 10.5 meters per second. Okay. Ang average velocity. Okay, so this is actually average velocity. Okay. Now at delta t equals 0.01 second, kailangan natin hanapin ngayon yung ang T2 nga natin ngayon is 1.0 seconds plus 0.01 seconds, so 1.01 seconds. Ang x at T2 or x at 1.01 seconds ay 25.1005 seconds. So ang average velocity in this case ay 25.1005 seconds minus 25 meters divided by 1.01 seconds minus 1.0 seconds, or this will be 10.05 meters per second. And pag delta t equals 0.0101 seconds, ang makukuha natin na average velocity ay 10.005 meters per second. So, anong napapansin natin dito? Okay. At pag ng delta t is 0.01 seconds, ang average velocity is 10.5. Pag ang delta t is 0.01 second, ang average velocity is 10.05. At pag ang delta t is 0.001 second, ang average velocity is 10.005. So, according to this definition, habang pinapaliit natin yung delta t, okay, ano yung limiting value? Ang limiting value is nag-approach siya sa 10. Nag-approach siya sa 10 meters per second. So instantaneous velocity is 10 meters per second. Okay, and yan. And makikita naman natin actually yun if we use calculus. Okay, so we know that x equals 20 meters plus 5.0 meters per second squared t squared. And ang instantaneous velocity is dx dt. So if we take the derivative of x with respect to time, we have 2 times 5.0 meters per second squared times t. And at t equals 1 second, makikita natin na yung velocity, instantaneous velocity is 10 meters per second squared times 1.0 seconds. So magka-cancel yung isang second dyan. So ang velocity is 10 meters per second, okay, which is pareho sa na-compute natin kanina. Now, to answer yung letter D, at t equals 2 seconds, okay, yung velocity, instantaneous velocity is 10 meters per second squared times 2 seconds. So yung instantaneous velocity is 20 meters per second. Okay. So, anong sinasabi niyan dito sa figure? So we have this average velocity here, okay, na nakuha natin to be saan na yun? 15 meters per second between T2 at saka T1. Pero at this position, x1, yung kanyang instantaneous velocity is 10 meters per second. And dito naman at T2, yung kanyang instantaneous velocity is 20 meters per second. Okay, so yun yung din-describe nung nangyayari dun sa cheetah. Okay, and yung interval, the total distance na kinover niya dito is 15 meters. So yeah, this distance is 15 meters. Okay, so yun yung ibig sabihin ng mga numbers na na-solve natin dun sa problem. Okay, so we can try to further understand yung results ng calculations by taking a look at this graph. Again, when you see a graph, tignan nyo kung ano yung nasa y-axis and ano yung nasa x-axis. So this is a displacement versus time na graph. So tatlo yung graphs dito kasi itong graph na to describes actually yung nangyayari sa ang tawag dito dun sa cheetah. In this case, ang reference dito ay reference time is t equals 1 seconds. Okay, so pag ang pinili natin na delta t dito is 3 minus 1, so 2 seconds. Ang makukuha niyong average velocity is 75 meters per second. So yan yung maano dyan. Tawag dito, yun yung mako-compute. And this was obtained using equation at 20 meters plus 5 meters per second squared t squared. Okay, makikita nyo naman yun kasi kung if you plug in 3 seconds dito, then this is 3 squared, so 9 times 5. Sorry, 2 seconds, and delta t is 2 seconds. So 4 times 5, 20, 40. Wait. 3 seconds. Okay, so my mistake. This is not a description of yung behavior ng cheetah. So this is something else. This is a new graph. Okay, so if you don't have the equation, if you don't have the position equation or equation for the position, but what you have is this graph. Okay, ang pinapakita dito is that okay, so ulitin natin. So again, this is a position versus time na graph. So basically, if you start at P1 and end at P2, ang P1 is at 1 second and at P2 is at 3 seconds. Tapos yung delta X ng P2 at saka P1 is 150 meters. Okay, yung average velocity is 75 meters. Okay, so that's 150 divided by 2 seconds, so 75 meters per second. Now, if you decrease yung delta t, okay, from this graph, you get at t2 equals at t equals 2 seconds, you get this position, and at t equals 1 second, you get this position. Yung delta x ngayon is 55 meters base sa graph sa blue line na yan. And yung delta t is 1 second. Okay. So your average velocity in this case is 55 meters per second. But if you make delta t extremely small, okay, so magpili ka ng delta t which is in the same order as the example, 0.1, 0.01, 0.001, okay, then you get a line with a slope of 40 meters per second. Okay, so itong line na ito ay may slope na 40 meters per second, and that's your instantaneous velocity. So makikita nyo na habang pinapaliit yung delta t, Okay, nag-approach siya dun sa instantaneous velocity niya. So mathematically, what we see here is the instantaneous velocity is nothing but the slope of the tangent line at a particular time in the displacement versus time graph. Okay. Okay. Now, if you see a displacement versus time graph, pwede na natin interpret ngayon kung ano ang nangyayari dun sa object. So, if what is given to you is this graph, okay, itong graph na ito na x versus t, displacement versus time. Okay, paano nyo ngayon interpret yung kanyang motion? Ano nangyayari sa object? So, the object starts at point A, moves to point B, then to point C, D, and E. Now, the y-axis is the displacement, and the x-axis is the time. So at t equals 0, it's located at position A. Okay. And then at ang position A is ito yung origin, and it's below or nandito siya sa negative x-axis. So it's to the left of the origin. So kung ito yung origin, is to the left, yung position niya is to the left of the origin. Yung position B is at x equals 0. So nandito siya sa origin. Yung position C is positive. Okay? So it's to the right of the origin. Yan yung position C. Yung position D is also positive, but less than yung position C. So it's somewhere here. And yung position E is very near the origin. So it's somewhere here. Okay? So yun yung mga positions. What about yung velocities? So to get the velocities, you draw a tangent line at each of these points. Itong kulay green na to, at point A, okay, that's your tangent line at point A. And yung slope na yan describes yung instantaneous velocity niya. So it has this much instantaneous velocity. That's yung slope at point B, okay, nandun na siya sa origin. Pero yung instantaneous velocity niya is may ganitong slope. Itong slope na ito is steeper than this slope sa point A. So, ibig sabihin, yung instantaneous velocity at point B is greater than the instantaneous velocity at point A. So, when you draw a vector, it should be larger or longer than the velocity vector that describes the instantaneous velocity at point A. At point C, if you draw a tangent line, dyan sa point C, kikita nyo na yung tangent line is horizontal. Okay. This means that the slope, okay, since the slope of that line is 0, yung instantaneous velocity at point C is also 0. So at point C, okay, wala kayo drawing na vector dyan. Okay, kasi yung instantaneous velocity is 0. Then at point D, yung tangent line has this slope. Compared to point A at saka point B, yung slope ng tangent line is parang nagle-lean towards the left. Diba? Medyo left-leaning siya. Which means na ang slope niya is negative. So, ibig sabihin, yung velocity is pointing towards the negative x-axis. Okay? And mapapansin nyo na yung slope niya is almost comparable or slightly less, diba? Slightly less than yung slope at point B. So, drawing tayo ng arrow which is a slightly less length compared dun sa arrow sa vector at point B. Okay, and then at point D, ito yung slope nung tangent line. Okay, so medyo mababa na yung slope niya. Okay, ibig sabihin mababa na rin yung kanyang instantaneous velocity. Okay, so and it's also leaning towards the left. So ibig sabihin negative yung kanyang slope. So nakaturo towards the negative x-axis yung velocity, instantaneous velocity ng particle at point E. Okay, so if we draw all of that information in this graph, okay, then we see what is really happening in sa particle. First, it starts from this position. Okay, then it moves towards the origin. And since lumalaki yung kanyang magnitude, yung speed niya, ibig sabihin, nag-increase yung kanyang speed, so nag-accelerate siya. Then at point tawag dito, at point C, naging zero yung kanyang speed. So somewhere between point B and point C, nagdi-decrease yung kanyang speed. And then as it goes from point C to point D, okay, first of all, nagbago ng direction. And then secondly, nag-increase yung speed. Okay. So, nag-increase yung speed from point C to D. Pero from point D to E, okay, nag-decrease yung kanyang speed, pero dun pa rin sa direction. Pero dun pa rin sa same direction. Okay, so bumilis papunta dito, bumagal papunta dyan, bumilis ulit papunta dito, pero nag-change ng direction, and then bumagal papunta dyan. Okay, so yun yung nangyayari dun sa particle. Okay, and all of that you can deduce from the line, okay, that is in the displacement versus time na graph. Okay. So, now that we know kung ano yung average, average velocity, tsaka instantaneous velocity, we also know displacement at tsaka time, we can now define yung average acceleration. And yung average acceleration is defined in terms of yung change in velocities. Okay. So the average acceleration we symbolize as A average, or dun sa textbook, in some textbooks they write it as A sub av dash X. Yung X of course indicates na nasa along the X-axis yung movement, yung av is yung average acceleration. Okay? And yung definition yan is the same as yung definition ng tawag dito, average velocity in mathematical form. So average acceleration is the change in velocity divided by the change in time. Okay, so the final velocity minus the initial velocity divided by yung final time minus yung initial na time. Okay. And we can also define yung instantaneous acceleration, okay, which we simply write as A, okay, to be equal to the limit of the average acceleration as delta t approaches 0, or the limit of delta v over delta t as delta t approaches 0, or dv dt, the derivative of the velocity with respect to time, or the rate of change of the velocity with respect to time. Since ang velocity is the time rate of change of that position, then your acceleration is the second derivative with respect to time ng position. Okay, so that's how all of these variables are related to each other. Okay, so now consider natin itong problem na ito. So this is also another example from the same reference, Young and Friedman. This is example 2.2. In this example, merong astronaut that has left an orbiting spacecraft to test a new personal maneuvering unit. As she moves along a straight line, her partner in the spacecraft measures her velocity every 2 seconds, starting at time equals 1.0 seconds. Okay, so ito yung na-measure niya na velocity ng partner niya. At 1 second, it's 8.8 meters per second. 3 seconds, it's 1.2 meters per second, and so on and so forth. Notice na at 9 seconds nagkaroon ka ng negative velocities, which means na most probably between 7 and 9 seconds, merong change in direction na nangyari. Okay, so the problem is to find the average x acceleration or acceleration along the x-axis and state whether the speed of the astronaut increases or decreases over each of these 2-second time intervals. Okay, so letter A from 1 to 3, letter B from 5 to 7, letter C from 9 to 11, and letter D from 13 to 15 seconds. Okay, so to find the average acceleration along the x-axis, okay, we use yung definition of average acceleration. Okay, so the average acceleration is delta V over delta T. This is along the x-axis. So hindi ko nilalagay yung mga subscripts for now. Okay, and for letter A, from T1 equals 1 second to T2 equals 3 seconds. Okay, from here to here, so yung average acceleration is 1.2 meters per second minus 0.8 meters per second divided by 3 seconds minus 1.0 seconds. This gives us 0.2 meters per second squared. Okay. Letter B. So yung letter B is from T1 equals 1.2 T1 equals 5 seconds. 5 seconds to T2 equals 7 seconds. So yung average velocity dito is 5 to 7. Okay. 1.2 meters per second to 1.6 meters per second divided by 7 seconds minus 5 seconds. So this gives us negative 0.2 meters per second squared. So C from T1 equals 9 seconds to 11 seconds. So yung average velocity is negative 1.0 meters per second minus negative 0.4 meters per second. So 9 seconds minus, or 11 seconds minus 9 seconds. This gives us negative 0.3 meters per second squared. And letter D, T1 equals 13 seconds to T2 equals 15 seconds. So yung average velocity is then negative 0.8 meters per second minus negative 1.6 meters per second divided by 15 seconds minus 13.0 seconds was 0.4 meters per second. Okay, so dito, so since this is, ang nangyayari sa letter A is that nag-increase yung kanyang speed. So ibig sabihin nag-accelerate siya. So positive yung kanyang acceleration. So you have a positive acceleration if the speed is increasing. Dito naman, from 1.6 to 1.2, nag-decrease yung kanyang speed. So meron kang negative acceleration. And that negative acceleration is shown by the negative sign dun sa acceleration. Dito, nakikita nyo na naging more negative from negative 0.4 meters per second to negative 1.0 meters per second. So nag-increase yung kanyang yung magnitude ng acceleration niya ay nag-increase. And yung acceleration is also negative kasi naging more negative yung acceleration. Dito naman, from negative 1.6 to negative 0.8, so nag-decrease, okay, yung acceleration. Okay? So, ibig sabihin, positive yung acceleration dito kasi naging less negative yung kanyang acceleration. Okay? We can see that from this graph. So, ito yung 0.2 meters per second. Okay, nag-increase yung kanyang speed and yung kanyang velocities. So yung acceleration niya is positive. Dito, nag-decrease yung kanyang velocities. So yung acceleration is negative. Dito, nag-increase pa further or naging more negative yung acceleration. So yung speeds. So yung acceleration increased further or decreased further, became even more negative. Dito naman, nag-increase yung velocity or naging less negative. So magiging positive na ngayon yung acceleration dito. Okay, so that's how you describe yung accelerations ng object. And yeah. Okay. So let's see. Now, in this particular case, titignan nyo yung graph. Yung graph na ito now describes yung velocity versus time. So this is a velocity versus time na graph. Okay, iba na to dun sa position versus time. Okay, so now this is velocity. We know that the average acceleration, okay, sorry, we know that the acceleration is just dx dt. And mathematically, this derivative is just the slope of the tangent line, okay, at a specific point. Similar sa velocity, dx dt. Kung tinitingnan natin yung position versus time na graph, we interpreted yung slope ng line sa position versus time na graph to be that instantaneous velocity. Dito rin, when we see a velocity versus time na graph and we measure yung slope or we determine the slope of any line at this curve, the slope of that line is the acceleration. Instantaneous acceleration, to be more specific. So yung figure is the green curve, okay, on a velocity versus time na graph. And we pick specific points dun sa figure. Point A, point B, point C, point D, and point E. At point A, yung velocity is negative kasi it's below the origin. Okay, so velocity is negative. So that means it's pointing towards the left. Okay, if you choose a positive x to be towards the right. Okay, yung letter B is at the origin. So ibig sabihin yung velocity, instantaneous velocity is 0. Letter C is above the origin. So yung instantaneous velocity is positive. Letter D is again at the origin. So yung instantaneous velocity is 0. Then yung letter at point E, yung instantaneous velocity is at below the origin. So yung instantaneous velocity is negative. So yung vector that describes that velocity is pointing towards the left or is negative. Now, the slope of the line at point A, yun yung orange, so it's leaning towards the right. That means that the slope is positive. Okay, it has a certain magnitude described by yung slope. So, ito yung acceleration niya, okay, at point A. Yung acceleration at point A. Now, yung at point B, nakita natin na may slope pa rin siya pero medyo nag-tilt pa siya towards the right. So, ibig sabihin yung slope is positive, but yung slope na yun is less than the slope at point A. So, nag-decrease yung kanya acceleration. So, yung vector that describes the acceleration has a smaller magnitude, smaller length. At point C, yung acceleration is 0 kasi yung slope ng line at point C, slope ng tangent line at point C is horizontal. It's 0. Okay. At point D, nagli-lean towards the left yung line, yung tangent line. Ibig sabihin, negative yung kanya acceleration. So, nakaturo yan towards the negative x-axis. And yung at point E, leaning towards the left pa rin, so the slope is negative, but the slope is greater than yung slope at point D. So, mas mataas yung acceleration at point E. And then it also points towards the negative x-axis. So, when we draw that behavior, okay, dito sa curves na ito, we can see how the velocity changes. Okay, so velocity increases, increases, becomes less negative from here to here, and then it increases further, and then decreases, becomes more negative. Yung acceleration naman decreases, okay, becomes 0, and then the acceleration decreases, it becomes more negative, then it becomes even more negative at point E. Okay, so yun yung behavior ng particle. Okay, dyan sa ano na yan, dyan sa graph na yan. If we interpret yung graph na kulay green, sa V versus T na. Okay, oops. Right. Keep that. And if we take a look at this, kung anong nangyayari dito, okay, and we now include yung acceleration. Ang gawin natin is malakihin natin ito ng konti. Sa gitna. Yeah. Okay. Now, ang tinitignan natin ngayon dito is an x of displacement versus time graph. Yung displacement versus time na behavior is described by this blue curve. Okay, now we are going to include yung interpretation ng acceleration. Okay, so yung velocity is, instantaneous velocity is the time rate of change of the position. And mathematically, this is the slope. Now, acceleration is the second derivative of position with respect to time. And mathematically, this is called the curvature. So, if the curvature is positive, okay, meaning ganyan, okay, it's curving upward, then the acceleration is greater than 0. If the curvature is negative, meaning it's downward, yung curvature niya, then the acceleration is less than 0. Okay, so from the x versus t graph, we can get information about the velocity, instantaneous velocity, and the acceleration. Okay, so at point A, what do we have at point A? So we have a negative position. merong slope yung green, yung tangent line. And the slope is positive kasi it's tilting towards the right. And since may curvature ka na upward, then the acceleration is also positive. At point B, yung acceleration, at point B, yung position is at x equals 0. It's at the origin. So nasa origin siya. Yung slope ng tangent line is greater than the slope of the tangent line at point A. So ibig sabihin, mas mataas yung kanyang velocity. Positive yung velocity. And then yung acceleration is 0 kasi it neither curves upward or curves downward. It's actually at the point of inflection. So the acceleration at that point is 0. Now at point C, the position is positive. At that position, yung velocity is 0 kasi yung slope ng tangent line is 0. And yung acceleration is downward, so the acceleration is negative. Okay, at point D, okay, yung position is also positive but less than yung position at point C. Tapos yung slope ng tangent line is tilting to the left, so negative yung velocity niya. And the acceleration here at that point is 0 kasi it's the point of inflection. So hindi siya nag-curve upward or downward. At point E, okay, the velocity, at position is still positive. It's above the origin. Yung velocity niya is described by the tangent line, the green line. The tangent line at point E, so it's also tilting to the left. But the slope is less than the slope at point D. So ibig sabihin it has less velocity. It has less net velocity at point E. Okay. Pero yung acceleration is pointing, is curving upward. Okay. So, pwede natin i-describe kung ano nangyayari. Sa point A, the acceleration is positive. So, anong mangyayari pag acceleration is positive? Mag-increase mag-increase yung speed. At point B, yung acceleration naging 0. So dahil 0 yung acceleration, okay, at that point, okay, walang mangyayari sa velocity niya. Kaso, from point B to point C, makikita nyo na nag-change yung direction ng acceleration. So nag-point siya towards the left. So kaya naging 0 yung velocity niya at point C kasi somewhere between point B and point C, yung acceleration, okay, yung acceleration ay nag-change ng direction and nag-increase dahan-dahan. Now, from point C to D, since your acceleration is pointing towards the left, mag-speed up yung object towards the left. Okay? And yung acceleration naman dito ay bumababa hanggang sa maging 0. Then, from point D to E, nagbago na naman yung direction ng acceleration. So, nag-increase yung kanyang magnitude, yung acceleration towards the right. So, yung velocity ng object towards the left ay nag-decrease. So, yan yung nangyayari dun sa object. Okay. So, makikita natin na yung behavior ng particle, this depends sa kung ano nangyayari sa acceleration. And dun sa previous na figure, yung acceleration was not constant. In this figure, makikita natin na if you have a constant acceleration, makikita nyo na yung orange arrows ay hindi nagbabago yung length. So yung vector quantity that describes this acceleration is constant. Same magnitude at any given time. Pero ang nangyayari sa velocity is nag-increase yung kanyang magnitude, nag-increase yung speed, nag-increase yung velocities. Okay? Furthermore, yung increase ng velocity is at in equal amounts, okay, for the same time intervals. Ibig sabihin, if this time interval from here to here is delta t, then there's a corresponding change in velocity. And if this delta t changes by twice the amount, okay, yung velocity also increases by twice the amount. Okay, so ganun yung nangyayari. 3 times the amount, 4 times. So this is 3 times the amount compared to this. Okay, and for delta t, so this is 4 times the length compared to that. Okay, pag constant yung acceleration. Okay, mas magiging obvious to later when we discuss yung examples. Okay. Okay, so we defined yung we already defined at this point, we already defined yung displacement, yung time, average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. We have related itong mga quantities na to more or less sa isa't isa. For example, yung average velocity is delta x over delta t. And yung instantaneous velocity as limit as delta t approaches 0 ng delta x over delta t or yung derivative with respect to time rate of change ng position. We also define yung average velocity to be delta v over delta t and yung instantaneous velocity to be the limit of delta v of the average velocity as delta t approaches 0 or yung derivative with respect to time ng velocity. It's also the second derivative with respect to position with respect to time ng position. Now we have these definitions, but we actually don't know how to relate each of these to each other. For example, yung we know yung relationship nila through calculus, but halimbawa gusto mong hanapin yung position niya at a specific time given yung acceleration or kung ano yung velocity niya, final velocity niya given yung acceleration and yung positions, ganun. So wala tayong, at this time, wala pang ganong klaseng relations between them. So let me just summarize yung 4 equations, okay, that describes yung relationship between them. And we call them the equations of motion, or in some textbook, these are the kinematic equations. Okay, so the equations of motion na ito, simulan natin sa position. Okay, so position, this is the final position, this is the initial position x naught, plus yung initial velocity times time, okay, plus 1/2 acceleration times time squared. Ngayon, lalagay ako ng subscript x dito at saka ng subscript x dyan para i-describe, para sabihin na itong equation na ito describes yung velocity niya, initial velocity niya, describes yung initial velocity along the x-axis at yung acceleration niya describes yung acceleration along the x-axis. So this is the acceleration along the x-axis, and when we say acceleration, is the instantaneous acceleration. Ito naman is the initial instantaneous velocity along the x-axis. Okay, so this is of course the initial position, And this is the final position. Okay, yung t, of course, is time. Second equation is Vx equals V naught x plus 1/2 a sub x t plus 1/2 plus a sub x t. So now this is the instantaneous velocity along the x-axis, or we can say na final instantaneous velocity along the x-axis. There's third equation, which is Vx squared minus V naught x squared is equal to 2ax x minus x naught. And the fourth equation, which is x minus x naught equals 1/2 V naught x plus Vx times t. Okay, so we have these four equations, and these are the equations. Kung meron man kayong tatandaan, yan lang mga kailangan yung tandaan na equations. In general, in most problems, yung tatlong equations niyan is already sufficient kasi this equation can be derived from these three, using any of these three equations. Okay, so now let's consider an example on how to use these kinematic equations. Okay, so in this example, we have a car entering the freeway. So a car sits on an entrance ramp to a freeway, waiting for a break in the traffic. Then the driver accelerates with constant acceleration along the ramp and onto the freeway. The car starts from rest, moving in a straight line, and has a speed of 20 meters per second when it reaches the end of the 120-meter long ramp. So, tignan muna natin, ano bang nangyayari? Paano nyo na-imagine itong nangyayari dito? So, you have this freeway, and then somewhere here, merong ramp. Okay. Okay, so ito yung freeway, then maraming kotse dyan, mga takbo, diba? Ito yung mga lanes. Okay. And then, sits on the freeway. Car sits, or car sits on the entrance of the freeway. So, yeah. Waiting for dito. Yan yung entrance ng freeway, ng ramp. So, yan yung ramp. Ito yung freeway. Okay. Okay. So, yung ramp na yan is 120 meters. Okay. Medyo hindi accurate yan. So, ganyan yung itsura niya. So, this is about 120 meters. Okay. So, what is the, well, ang mangyayari dyan is, naghihintay siya ng opportunity niya para makapasok. Okay. So, it starts from rest. So the car starts from rest. Okay, and moves in a straight line and has a speed of 20 meters per second. So, dyan siya mag-move along the ramp. Okay, bago siya mag-merge onto the traffic. Okay, so, ano yung mga alam natin? Ang gagawin natin first of all is to determine kung ano yung alam nating quantities. Okay, so what do we know? You always start with what we know. Begin with what we know. Okay, so alam natin na if the car starts from here, then we can assign that as the initial position. We let that be at the origin. So that's at x not equals 0. Okay, then we draw a coordinate system. Okay, yan ang ating coordinate system, positive x. Oops, sorry. Ulitin ko. Instead, gagamitin ko dito is black. Okay, so yan yung coordinate system and yung positive x-axis. Okay, notice na ang ginamit kong coordinate system dito is parang vertical kasi ang drawing, o pag-drawing ko ng ramp is vertical. Pero pag dinawin niyo yung ramp na horizontal, then i-orient niyo lang yung ramp accordingly. Horizontal na rin. So, if this is x naught, oops, this is x naught, then this is yung kanyang final position, which is 120 meters. Okay, so yung final position niya is 120 meters and yung initial position niya is 0. Okay? Ano pang alam natin base dito? Ang speed niya is 20 meters per second. Okay? Now, yan yung mga obvious, di ba? Kasi may speed siya ng 20 meters. Okay, ang position niya raw is 120 meters. So yung at 120 meters yung speed niya is 20 meters per second. So yan yung kitang-kita nyo kaagad. Now, ano yung mga given na hindi obvious? Well, first of all, yung initial position niya, kasi tayo nag-define ng initial position. So, ililipat yung x naught doon. And at that initial position, yung speed niya is 0. Saan natin makikita yun? Okay, saan yan? So, it starts from rest. Okay. So, yun yung nasasabi na yung speed niya is 0. Okay. Ano pa yung mga hindi obvious? Meron siyang constant na acceleration. Okay, so constant yung acceleration niya. Okay. Now, ano pa yung ibang ano dito? Hindi obvious na quantities. Okay. So mamaya, may babanggitin tayo na isa pa mamaya. Okay, now, before we proceed, I'd also like just to mention na itong mga quantities, itong mga equations of motion na ito only work if the acceleration is constant. So yan yung unang assumption ng pag-derive dito. Acceleration is constant. Second, you consider all objects to be point objects. Okay? So wala tayong pakialam at this point sa length, width, sa dimensions ng objects. So all objects are point objects. So since this is a constant acceleration, okay, pwede nating i-derive pwede nating makuha yung mga kailangan natin malaman from any of those four equations. So letter A, what is the acceleration of the car? Okay, so ano yung acceleration daw ng vehicle? So, tignan nyo, ang alam natin is initial and final position, tsaka initial and final velocities. Of these four equations, ano yung mga pwede nating, ano equation ang pwede natin gamitin? If we use this first one, if we try to use the first one, problema tayo kasi hindi natin alam yung time. Ganon din para sa second. And para sa fourth. Hindi natin alam yung time. Pero sa third, we know yung initial final velocities, initial final positions, and we can actually solve for the acceleration using the third na equation. So letter A, we can solve letter A by using the third equation. So b squared is equal to v naught squared, b squared, vx squared is equal to v naught squared x plus 2ax x minus x naught. So yung acceleration is equal to vx squared minus v naught x squared over 2x minus x naught. So this is 20 meters per second squared minus 0 squared over 2 times 120 meters minus 0. So yung acceleration na ito ngayon is equal to 1.7 meters per second squared. Now, we are expecting na acceleration is positive kasi yung velocity increased from 0 to 20 meters per second. So we are on the right track. Okay, dahil positive yung nakuha natin yung positive yung nakuha natin acceleration. Yung letter B, how much time does it take the car to travel the length of the ramp? So now we are looking for the time. If we go back dun sa apat na kinematic equations natin, we can use the first one, okay, but we'll end up with a quadratic equation kasi may t squared tayo dun, di ba? Okay, kung marunong kayo mag-solve ng quadratic equation, you can use that. You can also use the second one kasi alam natin yung final, yung initial, at yung acceleration. Okay, and this is a linear equation, so this is a much easier equation to use. You can also use the fourth kasi linear pa rin siya with respect to time. Okay, and alam natin lahat ng quantities na yun. So if we use yung second equation, so we have Vx is equal to V naught x plus axt. We can solve for time to be Vx minus V naught xt over a sub x. So this will be equal to 20 meters per second minus 0 meters per second divided by 1.7 meters per second squared. So yung t is equal to 12 seconds. Okay, so letter C, the traffic on the freeway is moving at a constant speed of 20 meters per second. So in other words, yung mga kotse na ito, yung mga kotse na yan, they are already moving at 20 meters per second and they're moving at constant speed. So constant speed of 20 meters per second. So yun yung third na tawag dito na hindi obvious kasi nakasulat lang sa text but you have to read. Diba? Kung ano yung nakasulat sa text. Constant speed of traffic on freeway of 20 meters per second. So ang tanong dito, what distance does the traffic travel while the car is moving the length of the ramp? Okay, so ano ang distance na travel no vehicles? Okay, so anong given dito? Given of course yung distance from 0 to 120. Constant yung speed niya, 20 meters per second. At dahil constant yung speed, yung acceleration is 0. That's another thing in this case na hindi obvious. Dahil constant yung speed, yung acceleration is also 0. Okay, for the cars na nandito na sa freeway, they're not accelerating. Okay, so base dun sa information na yun, anong equation ang pwede natin gamitin dito? Well, we want to find yung distance na travel nila, so we can use either the first, the third, kasi may distance yan, and then yung fourth. Sa third, sa first, pwede natin tanggalin yung term na ito kasi wala acceleration, di ba? And we can simply use yung initial velocity, which is 0. But then we'll end up with we can use the velocity to be equal to 20 meters per second. Okay, and yung time na 12 seconds. Okay, so we can use yung first equation. So x equals x naught plus v naught xt plus 1/2 axt squared. Okay, so this is 0. Remember, we're talking about yung cars na ito, hindi na itong kotse na yan. Okay? And yung velocity ng mga kotse na ito is 20 meters per second. 20 meters per second. So, yung initial position is 0 plus 20 meters per second. And for the same time, na 12 seconds, ano yung tinravel nila? Na distance ng mga kotse na ito. Ang tinravel nila na distance is equal to 240 meters. Okay, now this result, okay, now ang gagawin nyo ngayon is to analyze yung mga nakuha yung sagot. Okay, yeah. Okay, so andito na ngayon yung physics. Okay. Ano yung tawag dito? Ano yung mga physics dito? First of all, ito, dinetermine natin yung acceleration is 0 kasi constant yung speed. Then, of course, we know that the acceleration should be positive kasi nag-increase yung speed ng kotse na ito from 0 to 20 meters per second. And also, since itong mga kotse na ito are already traveling at 20 meters per second, yung distance na i-cover nila is farther than yung distance na ito-travel ng kotse na ito. Kasi this car actually starts from rest. So magsi-speed up pa lang siya. So that means na yung answer dapat sa C is greater than yung answer dun sa A. Is greater than 120 meters. And yun nga yung nakuha natin. Okay? Kasi nga, gumagalaw na itong mga to at constant speed. Okay, so nandoon yung mga physics. So yung mga calculations na ginawa natin dito, yan ay mathematics. But at the end of the day, you have to analyze kung ano yung results ninyo. Tignan nyo kung tama yung results at kung nag-make sense sila in terms of physics, in terms of kung ano yung talagang nangyayari sa tunay na buhay, di ba? And yun yung doon niyo i-apply yung physics, okay, dito sa problem na ito. Okay, so this result actually makes sense. Okay. Okay. Now let's proceed to the next problem. Yung next problem is about a tennis serve. So dito, we have the fastest measured tennis serve. The ball left the racket at 73.14 meters per second. The serve tennis ball is typically in contact with the racket for 30.0 milliseconds and starts from rest. Assume constant acceleration. Okay. A, what was the ball's acceleration during the serve? And B, how far did the ball travel during the serve? Now, kailangan nyo intindihin kung ano nangyayari ulit dito. Okay, hindi pwedeng banat lang kayo ng banat. So, when the ball hits the racket, yung strings ng racket specifically, it remains in contact, the ball remains in contact with the strings of the racket for a brief period of time. At yung time na yun is, in this problem, is 30 milliseconds. Okay? So, time is 30 milliseconds. Mag-ingat kayo dyan sa MS kasi marami nagkakamali minsan dyan sa, sa prefix na M. Yeah. So, yung small m is milliseconds. Okay? So, it's a very, very small time of contact between the ball and the string. Okay? And yung ball, as soon as it touches the string, ang initial speed niya is 0. Okay? So V naught is equal to 0 at T equals 0 seconds. Okay? Yan yung ibig sabihin ng starts from rest. So yan yung mga hindi obvious. Now, at T equals 30 milliseconds, yung velocity niya ngayon is 73.14 meters per second. Okay, if we assign yung t equals 0 seconds at position x naught or at the origin, okay, then itong velocity at 73.4 meters per second, yan yung final na position niya. We tawag dito. We assign that as x. Okay, yan yung kanyang final position. Okay. Then, pwede natin gamitin yung mga equations of motion natin. So, itong mga sinunod ko sa ibabaw, yan yung alam natin. Okay. Di ba? We always start with what we know. Ito naman nasa ibabaw, alam din natin yan, pero hindi siya obvious. Kailangan yung basahin ng mabuti yung text at tignan kung ano yung mga given na hindi ganun ka-obvious. Okay? Another thing that is not obvious is to assume constant acceleration. Okay, so ang nangyayari is, let's draw a coordinate system. Okay, we start from here, yan yung origin, and then ito yung positive x-axis towards the right. And then at this position, okay, nandiyan dyan, maghihiwalay yung bola at saka yung tawag dito yung bola from the racket. So ito yung initial contact. Okay, and then of the ball and the racket, and then ito yung release of the ball. Okay. And yung time interval is 30 milliseconds. Yung velocity dito is 0 kasi it starts from rest. And yung velocity dito is 73.14 meters per second. Okay. Okay. So ang tanong sa letter A is, ano yung acceleration? Okay. So A, what is the acceleration? So we know the time. We don't know yung displacement, pero we know yung change in velocity. So if we choose from these four equations kung ano yung pinakamaganda, it seems na itong second yung okay kasi alam natin yung final velocity, initial velocity, at yung time. Okay, time of contact. So, so we use that. So yung final velocity is equal to the initial velocity plus your acceleration along the x-axis times time. So yung acceleration along the x-axis is final velocity along the x-axis minus your initial velocity along the x-axis divided by the time of contact. So this is 73.14 meters per second minus 0 meters per second divided by 30 milliseconds. Now, don't forget to convert, okay? Okay, 30 milliseconds to seconds. So this is 1,000 milliseconds and 1 second. So this is 0.030 seconds. So yung acceleration ngayon is 2,438 meters per second squared. Letter B, how far did the ball travel during the serve? It's also dito ang pinapahanap is distance. It's also the same distance na kung saan yung bola ay in contact with the racket. Okay, so letter B, x equals, to determine yung distance, we can choose one of these four equations. Okay, so the first one, or the third, or the second, or the fourth. Okay, so we can choose either of these. Alam natin yung tawag dito, initial and final velocities. Okay, and alam natin yung initial and final positions. So we can use the first or the third or the fourth, right? So yung first na lang ang gamitin natin. So let's use the first. X equals x naught plus b naught xt plus 1/2 ax t squared. Now, yung initial velocity ng bola is 0. So that cancels out the second term. Okay, and then of course this is just 0. So x equals, what remains is 1/2 times 2,438 meters per second squared times yung 30 milliseconds This gives us a distance of 1.09 meters. Okay, so analyze. Does this answer make sense? And does this answer also make sense? Ibig sabihin, ang taas-taas ng acceleration. Well, of course, that makes a lot of sense kasi makikita nyo naman, over a short period of interval, biglang mag-increase yung speed niya from 0 to 73.14 meters per second. So it makes sense na yung acceleration ay mataas na mataas. What about this distance? 1.09 meters. Anong alam nyo na distance na about 1 meter? So you can use yung arm length. So yung arm length nyo is about 1 meter. Okay. So ibig sabihin, yung tennis racket move from this position, okay, to this position, okay, over a distance of 1 meter, okay, in 30 milliseconds. Ganun bang nangyayari sa tennis? Pag nanonood ba kayo ng tennis, nagta-travel ba yung racket ng 1 meter? Manood kayo, makikita nyo na it does travel over that distance. And sometimes, malayo, mas malayo pa o mas masigit pa sa 1 meter. So again, this answer also makes sense. Okay, so when you are analyzing, you have to go back dun sa nakikita nyo, okay, from experience. Kasi yung nangyayari sa tunay na buhay, yan, nandun yung physics. Okay? Wala dito sa mga mathematics na ito. So again, to analyze, you have to go back dun sa experiences ninyo or yung experiences na nakikita ninyo sa TV about yung motions ng iba't ibang objects. Okay. Now, this is motion, okay, that is specific, okay, that to an object is moving in one dimension. Now, there's another case na kung saan yung object also moves in one dimension, pero yung acceleration is due to a force, due to gravitational force. So here, include natin yung gravitational force. If you have gravity working, then yung acceleration is equal to the gravitational constant, a gravitational acceleration due to gravity. At ang value ng acceleration due to gravity is 9.8 meters per second squared. Okay, now here's the thing about gravitational acceleration due to gravity. So this is acceleration due to gravity. I mentioned earlier na magde-depend yung tawag dito. You can freely choose to use any type of coordinate system. And since yung velocities, since yung motion due to gravity is vertical, we use the y-axis instead. Now, typically, sa Cartesian coordinate system, yung y-axis, yung positive y ay paakyat. If we choose a positive y-axis, then your acceleration due to gravity is negative. Acceleration due to gravity is negative. Okay? Now, if you choose a positive y direction that is downward, okay, then your acceleration due to gravity is positive. Okay? Okay, so also keep in mind na yung acceleration due to gravity is neither positive or negative. Sorry, yung constant na acceleration due to gravity, yung constant na to is neither positive or negative. It's always equal to 9.8 meters per second. Kasi nga, first of all, constant siya eh. It is the acceleration that either becomes negative or positive. Depende sa choice ng coordinate system. I could never emphasize yung choice of the coordinate system enough. So you have to draw yung coordinate system, okay, in order to determine kung ano yung mga signs nung physical quantities. And makikita nyo dito na if you choose the wrong coordinate system, okay, or if you choose a coordinate system and define yung signs incorrectly, magmamali na lahat ng sagot ninyo. Okay, so yun yung ano dito nangyayari dito. So that's yan yung motion along the y-axis with gravitational force. So what changes dun sa apat na equations? So now we're going to use y. Okay, so y, yung initial position along the y-axis, final position along the y-axis. Y naught is the initial position. V naught y is the initial velocity along the y-axis times time, of course, plus ay t squared. Pero since ay is the acceleration along the y-axis, and if I choose the coordinate system to be positive y upward, then this becomes 1/2 gt squared. Okay? Yung velocity naman is therefore written as Vy, initial velocity along the y-axis, minus is equal to final velocity along the y-axis equal to initial velocity along the y-axis minus gt. So pinalitan ko lang yung ay ng negative g. Again, because I used this coordinate system. Then you have Vy squared is equal to V naught y squared minus 2gy minus y naught. And then, yung pang-apat, y minus y naught is equal to, okay, y minus y naught is equal to 1/2 Vy plus V naught y t. Okay, so again, it's the same set of 4 equations. You replaced, ang naging change lang is you replaced ay with negative g. And of course, pinalitan niyo yung subscripts from x to y, only because you're now using the y-axis as your coordinate system. Again, if you choose an axis which is positive y downward, then you don't need to change the sign. So ito magiging positive, yan magiging positive, at ito magiging positive. Okay? So, I hope na naintindihan niyo yung part na yan. Okay, so now let's consider a couple of examples. A rock is thrown straight up with an initial speed of 24 meters per second. Okay, neglect air resistance. At t equals 1.0 seconds, what are the directions of the velocity and acceleration of the rock? Is the speed of the rock increasing or decreasing? And at t equals 3 seconds, what are the directions of the velocity and acceleration of the rock? Is the speed of the rock increasing or decreasing? So anong alam natin ngayon? Start with what we know. What do we know? Yung initial velocity is equal to 24 meters per second. Walang air resistance. Okay, walang air resistance. Okay. Tapos, of course, we set up the system so that the initial position niya is at 0 at the origin. Okay, and if we choose positive y to be upward, then your acceleration is negative 9.8 meters per second squared. Okay, so at t equals 1 second, ano yung directions ng velocity and acceleration of the rock? Is the speed of the rock increasing or decreasing? So yung velocity, okay, is v naught plus, so Vy is equal to V naught y plus Ayt, sorry, minus gt. So this is 24 meters per second, okay, minus 9.8 meters per second squared times 1.0 seconds. Is equal to 14.2 meters per second. Okay, yan yung velocity of the rock at t equals 1 second. Ano yung acceleration of the rock at t equals 1 second? Of course, it's negative 9.8 meters per second squared. Now, the velocity is positive and the acceleration is negative. Imagine niyo yung acceleration, tulad sa figure kanina, yung acceleration ay pababa, yung velocity ay paakyat. So, mag-opposite sila in direction. So, ang mangyayari sa velocity is babagal siya. Yung speed niya ay babagal. At t equals 3 seconds, okay, ano mangyayari sa kanyang speed ngayon? So, this is 24 meters per second minus 9.8 meters per second squared times 3 seconds. Maging speed niya ngayon is negative 5.4 meters per second. Sorry, well, hindi per second squared, kundi per second. Okay? Yung acceleration niya is still negative 9.8 meters per second. Dahil yan sa gravity, hindi yan magbabago. Hindi magbabago ang gravity, di ba? Makita niyo na bumagal nga yung kanyang speed, naging more negative. Okay? Bumagal, nag-proceed to zero and then nag-increase ulit. Pero naging more negative, so yung velocity niya ay lumiit. Okay, so the speed of a rock actually decreased. Okay? To zero. And then at some point, nag-i-increase yung speed niya from 0 to 5.4 meters per second. Dito makikita niyo rin yung difference ng velocities tsaka ng speed. Okay? So, speed is just the velocity without the direction. Okay. So, anong nangyayari dito, bale? So, if we start from, if this is the position at t equals 1.0 seconds, okay, yung kanyang velocity is 14.2 meters. Okay? And paakyat siya. Positive kasi yung kanyang ano, di ba? And then at t equals 3.0 meters, so it will be somewhere here, I suppose. Okay, and yung speed niya is 5.4 meters per second, pero pababa na. Yes, smaller arrow. So nangyari is binato mo nga yung rock, di ba? At some point, naging zero yung kanyang velocity. Okay, and then nag-change ng direction kaya naging negative. Pero dito, nag-increase yung kanyang speed. Dito, nag-decrease yung kanyang speed. Nagpupunta sa zero. Okay, so this is at t equals 1.0 seconds and this is at t equals 3.0 seconds. Okay. Okay, then last problem, 2.45. A 15 kilogram rock is dropped from rests on the earth and reaches the ground in 1.75 seconds. When it is dropped from the same height on Saturn's satellite, Enceladus, the rock reaches the ground in 18.6 seconds. What is the acceleration due to gravity on Enceladus? So again, we start with what we know. Anong alam natin? We know that the mass of the rock is 15 kilograms. We also know na yung rock na yun, pag binato mo from the same height, okay, takes about 1.75 seconds sa Earth. And sa Enceladus, takes about 18.6 seconds. Okay, yung hindi obvious dito, they were dropped from the same height. They dropped from the same height. Okay, yan yung mga hindi obvious na quantities. Okay, ang isa pang ano dito, hindi obvious is it was also dropped from rest. So V naught is equal to 0. Okay, so anong pwede natin gamitin sa mga equations na yan? Well, we can use yung first, so equals x naught plus V naught x, or since ano to, no, may gravitational ano, no? So y is equal to y naught plus V naught yt plus 1/2 times acceleration on the earth times time on the earth squared. So y minus y naught is equal to V naught yt. Lipat ko lang yan doon sa kabila. And we are also assuming na yung physics is the same on Enceladus. So on Enceladus, we will be using the same equation. On Earth, on Enceladus, V naught yt plus 1/2 acceleration on Enceladus, time on Enceladus squared. The initial velocities are 0 on both equations. And these two are equal. So ibig sabihin, these two are also equal. So we can simplify the equation to be acceleration on the Earth, time on the Earth squared is equal to acceleration on Enceladus, and time on Enceladus squared. So the acceleration on Enceladus is equal to the time on the Earth divided by the time sa Enceladus squared times acceleration on the, and this will be equal to 1.75 seconds divided by 18.6 seconds squared times 9.8 meters per second squared. Hindi natin sinama yung sign kasi ang hinahanap lang naman natin ito obviously ay yung magnitude ng accelerations. So yung acceleration on Enceladus is 0.087 meters per second squared. Now, does this make sense? Tingnan niyo yung time ng paglaglag ng rock. Sa Earth, it's 1.75 seconds. Pero sa Enceladus, it's much, much longer. Ibig sabihin yung acceleration, dun sa planet, sa alien planet, must be much, much less than the acceleration of the Earth. Kasi ang tagal nung paglaglag ng bato. And yun ngayon nakuha natin. An acceleration that is much, much less than the acceleration due to gravity sa Earth. Okay, so this answer makes sense. Okay, so I hope na meron kayong tutunan today, and try to answer some exercises dun sa end ng chapters ng book. Okay, para lang ma-practice kayo. Support in practice is very important para lang masanay kayo na mag-solve ng mga problems. Okay, see you next week.